about a specific algorithm called as decision tree. Within decision tree, we discussed about various techniques, but what is the name of the algorithm that we have spoken about? The name of the algorithm is greedy algorithm. And within greedy algorithm, you choose that variable which gives you the highest information. So how do you calculate the information gained or information available within each and every variable? What is the formula for that? Entropy before minus entropy after. And this will help us calculate information gain for each and every variable. And then how do you choose a root node? Root node is that node which has the highest information gain. Okay, highest information gain, that's called as your root node. Okay, what is the formula for entropy? I equal to 1 until n, probability into log of probability. This is very important formula. Very, very important formula. Don't, forget that, please. Okay. Now we need to get into ensemble methods. Okay. What are the regularization techniques within decision tree? Pruning, absolutely. Yeah, absolutely. Within pruning, you have pre-pruning and post-pruning. In the interviews, people might ask you which of the hyperparameters or which of the regularization techniques fall under pre-pruning and what are the other regularization techniques which would be part of post-pruning. And you should be in a position to answer this. Okay. So that's about the decision tree. Okay. And then we switch to ensemble techniques because we understood that when we use a single algorithm, each time you split the data into training and test, and when you build a model, right, results might vary. There has to be a mechanism to run the algorithms multiple times on different data sets and then combine the results. That would bring more stability into your algorithm. Okay? It will not give you different results altogether because you're taking an average. Okay. Next, we have homogeneous and heterogeneous ensemble techniques. Homogeneous means we use the same base learner. Base learner means same algorithm. And we also have heterogeneous. Heterogeneous means you use different set of algorithms. So homogeneous, heterogeneous. And we also have generative versus non-generative. Generative means the results of one algorithm would move on to the next algorithm. Boosting, bagging, random forest. And when it comes to non-generative, they just take the results of the algorithms and combine the results in some way. What are the techniques? Voting and stacking. Within voting, you can have hard voting or you can have soft voting. Soft voting is nothing but taking an average. And within average, you have simple average and weighted average. Good. So we understood all of these things. Now let's get into bagging and let's understand more on bagging. Okay. Even before that, let's talk about sampling or resampling. Let me see if I've made a note of this. If not, that is absolutely fine. Because I will anyways. And I think that option or those details are not recorded by me in a detailed manner. Having said that, that should not bother us at all. Okay, so that's fine. So friends, ideally, what is sampling? Sampling means you'll have population. From this population, you take a sample. Correct? Since we cannot work on complete population, we get the sample out. This is sampling, right? Basically. Because we cannot take the entire data and we will not be able to get access to the complete data, we get a sample by performing a simple random sampling. From this sample, so this is the data set which will be given to you by the customer, for example, or this is the data that you collect. You obviously cannot get access to the complete population. So what do? You get sample. And once you get sample, what do? You are going to once again take that sample and split the data into training and test. That process is called as resampling. Ideally, it is called as what? Resampling. Okay, when you apply this resampling technique, what do you get? Subsample. Means from this sample, you're trying to get a smaller portion, which is called as a subsample. Or think about this as your training data set on which you're going to train your model. All these subsamples, think about these as your training data sets on which you train your models. And there is something called as bootstrap sampling. Or bootstrapping. Okay. So what do you mean by bootstrap sampling? Sampling with replacement. So suppose you have a sample of some 1,000 observations or 10,000 observations. Okay, say in this data set, you have your output variable and input variables. When you try to randomly take a sample into your training data, and then remaining, if you want to put it in test data set, for instance, say you want 80% of data into training and 20% of data into test. Then for this training, suppose randomly row number 2 is selected from these 10,000. Now, when the next observation should be randomly sampled, do you know what? Again, you're going to randomly sample from all 10,000. 2 got selected does not mean 2 will be removed. 2 got selected, you put it here. For the next sample, again, randomly from these, you select. Say you randomly selected row number 100. You put that. You mention. Then again, when you sample, probably 2 get selected once again. Because you're sampling with replacement. Okay, we are sampling with replacement. In that way, you select. Bootstrap sampling is what we call this as. When you create n number of samples like this, meaning you have come up with the training and test split. Again, you come up with another training test split. Again, you come up with again training and test split. Different times if you split it in this way with the replacement. People say that there is a specific rule, which is roughly 36% of the observations will not be selected at all. Out of 10,000 observations, roughly 36% of the observations will never be selected. Okay, let me give you the exact number so that I don't end up giving you a wrong number here. Okay, 36.8 to be exact. This is what people have figured out by doing a lot of experiments. That means each observation has a probability of getting selected in the samples for what percentage of times? 63.2% of times. Okay. That means 36.8% of the original data set, okay, would always be out of bag. It won't be in your training. It will always be out of bag. It won't be in bag. In bag is also called as in sample. Out of bag is called as out of sample. Okay, so 63.2% will be the probability of these instances to be selected in training data. 36.8% is the probability of each instance that it will be out of training data. Out of training means it can be part of validation data or test data set from machine learning or predictive modeling standpoint. You can do this experiment and you'll very soon understand this. Okay, next. Bagging means bootstrap aggregating. B stands for bootstrap. Aggregate. AGGING is for aggregating. AGG is for aggregating.